people use in managing resources, in provisioning resources, and then in how they decide pricing for those services. So those are market driven. So in which we have collection of interconnected computers that are virtualized. This is very important. So here, when consumers make access to the capability, they don't gain access to physical resource directly. They gain access to a virtual computer or a virtual machine, which will be mapped to a suitable physical machine as and when required, or moved to some other place. And that means these virtual computers are dynamically provisioned. So dynamically provisioned in order to make sure that user requirements are met, which are expressed in the form of SLAs. SLA is basically a negotiated and agreed QoS, quality of service. So both consumers and providers, they negotiate, and that once they agree to certain capability, that is QoS, then that becomes SLA. And SLA also will define what is called as penalties. For some reason, if provider is not able to honor those SLAs, they may have to violate. The violation leads to penalty. So this is what really cloud computing is all about. So in cloud, any cloud you pick up, so today's our cloud may not have all these characteristics that I mentioned, but that is the vision, and that is what you would see as time progresses. If you look at roadmap of various companies in cloud computing area, that is what they really promise. So key characteristics of this cloud computing, and unlike previous systems, are noted here, and some of them are very unique to cloud computing, or others have been there. For example, IT service oriented. So these days, as I said, any IT system is built using this service oriented architecture. Then this is the most important one, elastic in nature. So cloud infrastructure is elastic in nature. What it means is, so if you have an application services, you are demanding capabilities that you needed to host your application, the underlying infrastructure can be scaled out or scaled in. So you can stretch as your demand increases. When demand decreases on your services, you can decrease the amount of capability that you rent. So this is something elastic in nature, which is very important. So this was something that was lacking in previous systems. So dynamic, so it is obviously dynamic in nature, in a distributed nature, and it is shared. So because of this economy scale, then we can get services at a bit lower cost. Then, as I said, market oriented. The principles of market oriented are so fundamental here that are used in building building architecture and developing appropriate algorithms, which I will discuss more as we go along. Then, of course, this is autonomic in nature. That means the system must self-manage itself. You can't afford to have a human all the time managing the system. It must be autonomic. It must be automatic. Then virtualize. So as I said, when you gain access to a capability, you get access to virtual machine, which can be mapped to a physical machine, different location depending upon where the consumer is. So these are unique capabilities of cloud computing. If I have to pick up just one or two characteristics that are very unique to cloud computing, that would be elasticity and virtualize. So rest were there in previous distributed systems. So coming to other concept like cloud services, so in community, so we hear about cloud providing three kinds of services. The first one is called infrastructure as a service, cloud offering infrastructure as a service. Essentially, for example, you can rent CPU, storage and network capabilities from providers such as Amazon and GoGrid and few others. So that is the bottommost service layer. Then the topmost is called software as a service. So this is basically application services that you can rent. If you are a user, you probably don't want to focus on renting low-level things. You are really looking for application services. Then you want that provider to take care of the low-level stuff. You just focus on, for example, if you are renting a CRM services, customer relation management services, or HR management, any of these services, you focus on those application services. Then, of course, one can build those applications using this low-level, but it's too difficult. So developing application using infrastructure services is too complex, and managing and provisioning resources is complex. Therefore, in between we got what is called as platform as a service. So this platform as a service is a layer middle between applications and infrastructure, providing capabilities such as application development, deployment, and execution management. So these are this can be more like a middleware in a way. So there are, of course, companies such as Google and Microsoft and our own company Manjrasoft are playing a role here. So where you can lease this platform to build application and deploy and manage on this infrastructure. So and of course there are a number of companies are offering different stuff. So Amazon in infrastructure, Google is sort of platform and infrastructure combination. Then other company like IBM, Fujitsu trying to build what is called as private clouds. So I will discuss more as we go along. So other aspects. Then these clouds can be deployed globally and make it available to anyone in the world to consume. So those clouds are called as public clouds. they're also called as internet cloud. Essentially, this is a third-party infrastructure that can be rented by anyone, irrespective of which country they're coming from, irrespective of which organization they're coming from. So there is no distinction as such. So basically available on a pay-as-you-go basis. And this model is quite exciting, and then many people liked it, and they like to replicate same thing in their organization. For example, like university like Swinburne or Melbourne, they can set up one similar capability for its own use, but supporting various departments where they can pull in and then price. So these are called as private clouds. So private clouds are often set up for security concern reason. So sometimes some bank, for example, banks are not so much comfortable with outsourcing their requirements to public cloud, although they like it. Therefore, they are replicating similar concept within their organization called as private cloud or enterprise clouds. So like in a university setting, this is like a private tutoring, right? And this is more like a public lecture here, right? So often we use these two models in real world. Then there is something third called hybrid clouds. So essentially, this is a mixing model of both private and public cloud. So you still have a private cloud and you keep using capabilities. Whenever your requirements from private cloud are not being met by internal users, what do? So they should be able to dynamically or seamlessly acquire some additional capabilities from public cloud and use along with private cloud. So these are called as hybrid cloud. So these are the three terms that you often hear in cloud computing area. Okay, so of course all of these are driven by real world application. So people are not so much excited about building some computer science concept, but there are real world applications, usual scientific and technical applications. So I'm not emphasizing so much on them, but I like to highlight about cloud popularity for these consumer, social and business enterprise applications. Particularly these consumer applications, they are quite popular. For example, these are more of a consumer applications. Like for example, Twitter. Right? So most people have heard about Twitter, I guess, right? Either anyone who hasn't heard about Twitter here? I'm sure everybody's heard about it. So this Twitter is hosted on cloud. Like if you carefully watch, when you visit some site, if you carefully watch below, whenever some access content is pulled, the content is pulled from S3 storage from Amazon. You will see something s3.amazon.com, right? That means the content is hosted there and managed through like Amazon. Then there is something called Animator. So this is quite popular service. Like for example, if you visit some place, for holiday, like if you visit China Wall, for instance. So what do? We take a digital camera, and then now we have got people are so much addicted to digital camera. For a day visit, they would take about 200, 300 photos, and when you come back, you probably don't have time or energy to show it to anybody. What do? You may be having energy to show, but other people may be not ready to see it for 2 hours, all the 200 photos. So it is possible for you to convert those photos into a 1-minute video or 2-minute video with appropriate background music of choice of that person who is going to look at it. So you can easily convert into a small video those photos. So this company is offering such services like Animator. So this is hugely popular. So when they set up with within their organization. Then when this application become so popular worldwide, then they were not able to manage at all. So they have to move it to public cloud, wherein they can expand as demand increases. Whenever demand is less, decrease the amount of capacity that you rent. Similarly, we heard about Gmail and others. So these are the applications that are very popular today for cloud computing. But obviously, we need to see more enterprise applications in this space. So enterprise applications are coming. Applications like, as I said, CRM, accounting, or e-commerce, these are now more easily available on which you can rent and then integrate into your applications and offer the capability. Then more of real enterprises like banking and so on. So there are still security concern and trust concern. As these things resolve, we will see more and more of those applications coming to cloud environment. Okay, so that's about application. What about business potential? Is it business potential big enough that we can invest our time and energy? So here are the data from IDC. It's this is for 2008 worldwide IT spending about $400 billion. Something like 4% of that $16 billion went for IT cloud services. Rest on-premise IT. Then this is the projection for 2012. By 2012 it will be about something like $500 billion. And then obviously IT cloud services moves from 4 to 9%. That is about $42 billion. So this may not be a big amount, right? Big about business potential. So for a company like Microsoft to worry about. But however, if you look into the future, here is my guesstimate for 2016 and 2020. So by 2016, in my opinion, so this will grow to be something like $700 billion. So say, let us say 15%, about $120 billion. But if you move to year 2020, so with ubiquitous adoption of these capabilities, and all these underdeveloped and developing countries become prominent there, so easily we can expect anywhere between 30 to 40% of services that IT expenditure of something like, say, moving to say $2 trillion, half of that 30 to 50%, say $1 trillion opportunity by year 2020. This is one of the big reasons why every company that you can name are jumping into this area. So normally, for example, Microsoft, we expect them to focus on desktop PCs, right, PC operating system. So now they are losing sleep. So that is why they are so much focusing towards whether they can do something in cloud computing area. Otherwise, they become irrelevant, right? In 10 years' time, we may not talk about Microsoft. If you ask people, they might say, what is Microsoft, right? So therefore, so there's a huge focus in this area. So that means, so this such a potential may not be that easy to get. There are challenges that we need to address. What are those? Now let's take a look at challenges. The first challenge is virtualization. So often we think virtualization problem is solved. Actually, it is not. We have created more problems, right? So for example, you have you get customer requests and you create a virtual machine for each of the requests. What do you do with them? Where do you place them, right? For example, if there is a request for a service from a customer, you create a virtual machine. We need to decide where to locate it, right? Appropriate location and management. So if it is a content delivery oriented application, probably we need to locate that virtual machine close to a data center to that consumer. Thereby they can get a best service. So we cannot always put in one place. We should be able to move as people move. So that virtualization management. So next, the security, trust, and privacy. So these are the things that are really holding people from moving to cloud, particularly large enterprises and sensitive application. So there are necessary advances needed here to manage these aspects. Although personally I'm not that security expert, but however I can definitely say there are lots of trust issues, lots of security issues, and legal issues. How do we manage? How do we make sure that IT system conform to it? So next, pricing. So pricing is very important. So pricing is something that can make certain things popular or fail. So it needs to have a right pricing that is driven by quality, driven by demand and supply, driven by value they deliver. So then of course managing this billing and metering must be easier. Then quality of service and SLA. So this is something very important. So consumers will be able to negotiate. For a given service, quality expectation can change from time to time. So how do we deal with this automatically? So next, provisioning. So we need to provision resource such that SLA agreements can be met. If not, sometime you may be violating. How do you manage the risk? Managing risk is very important. So if you are violating some SLA, which of those SLAs you want to violate? You want to violate those that will have minimal impact on consumers and also minimal impact on you as a provider. And how do we do this automatically and dynamically? So next, scalability. So how do we make sure that this can scale? So because the moment our services move to cloud, so it is available to so many people around the world. So demand can grow exponentially. How do we manage this scale? So should we stick to a one cloud provider, or should we have a way of scaling our application across multiple cloud providers? Because no single provider can have a presence everywhere, right? Some cloud providers may be dominant here, some may be dominant elsewhere. So we need to make sure that our applications and the infrastructure can scale to different cloud providers. Of course, you are willing to pay price for it, but it's very important. Then this energy efficiency. These clouds are hosted by what is called as data centers. These data centers are known to be consuming huge amount of energy. For example, if you pick up a typical data center, they consume energy equivalent to 25,000 households electricity consumption. So imagine how much of electricity bill they have to pay. And I was told that data centers like Google data center, so the energy consumption of their data center is equivalent to entire city like San Francisco. So huge amount of energy. And on top of it, now we are talking about climate change, right? And there is a focus on reducing CO2 emission impact on environment. So IT today is contributing something like 2% of global global CO2 emission to the environment. So if you don't do anything by year 2020, it can go from 2 to maybe 15 or 20%. That's too much. So we need to make sure that our hardwares are energy efficient, our algorithms, operating system, resource allocation techniques are energy efficient. Like for example, today if you look at textbook like data structure and algorithms, when we talk about sorting, searching, and all these algorithms, we think in terms of their performance, measured by two parameters.